So this question says, given the rate of change of concentration of H2S, determine the rate of change of concentration of H2O. So if you haven't already watched question 1A, I would suggest starting with that. But in this case, what we're going to use is the same idea, all right? So here, the rate is going to be equal to, for H2S, which is one of the things that we're given, it's going to be negative, because H2S is a reactant, 1 over 8, the stoichiometric coefficient, delta concentration of H2S over delta T. And this is the rate of change, and this is actually what we're given here. Equals, and now we need to do it for H2O. For H2O, it's going to be positive 1 over 8, because it happens to be they're both 8 as stoichiometric coefficients, delta concentration of H2O over delta T. And note that this whole thing is the variable that we're trying to solve for, because we're determining the rate of change in concentration. We're not determining the change in concentration itself. So we want the concentration over delta T. In this case, we don't have a delta T, so it wouldn't be possible to determine the change in concentration. In part 1B, question 1B, it would be possible. All right. So in this case, this is what we're given here. So negative 1 over 8 times negative 0.0041 molar per second equals 1 over 8 delta concentration of H2O over delta T. And again, this whole thing is what we're going to solve for. Now, if you look here, you're going to take this negative 1/8 and divide it into this one. So essentially you're going to divide this by 8, and then you're going to multiply it by 8 again. So essentially, in this case, you're just going to make this as a positive number. So the delta H2O over delta T is going to be equal to positive 0.0041 molar per second. And the only reason that that's exactly the same number here, except it's positive, is because this is an eighth and this is an eighth. If you were asked about S8, then it wouldn't be the exact same number here, because they wouldn't have the same stoichiometric coefficient. But because they have the same stoichiometric coefficient, the only difference is this is a negative rate because this is a reactant, and this is a positive rate because it is a product.